All right, welcome to 6.1, sample space and addition rule, so more probability and statistics. Okay, so we're going to start off by vocabulary so that we can understand some of these. An event is an activity or an experiment which is usually represented by a capital letter. A sample space is the set of all possible outcomes for an activity or an experiment. A smaller set of outcomes from a sample space is called a subset. The complement of a subset is all outcomes in the sample space that are not part of the subset. A subset and its complement make up the entire sample space. If a subset is represented by A, then the complement can be represented by any of the following. We could say not A. This little symbol here means not A. Or we can say A to the C power, which means the complement of A. And so you'll see those interchangeably. I personally like that one, but you will see all of them. So here, let's look at the sample space, the possible subset, and what its complement would be based on a given thing. So if we're going to flip a coin, there's only two things that can happen. You can get heads or you can get tails. So that's our sample space. A possible subset, and we can write this as a set. So we're going to say S is our sample space. It's heads and tails. The possible subset, we'll call it B, and we can say maybe that's heads. So the complement of B would be tails. Because together, B and not B make up our sample space. Okay? If we roll a dice, or die, I guess technically is the correct singular term, we can get a 1, a 2, a 3, a 4, a 5, or a 6. Let's give maybe the sample space of evens. Let's call it A, so 2, 4, and 6. And then its complement would be the odds, 1, 3, and 5. Okay, if we pick a digit between 0 and 9, our sample space would be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Maybe we can have a possible subset that's primes. Let's just call that B again. So the prime numbers would be 2, 3, 5, and 7. And not B, so our complement would be all the other numbers. So 0, 1, 4, 6, 8, and 9. Okay? So now we have some vocabulary. Again, so we have the definition. It says the union of two events include all outcomes from each event. The word union can be indicated by our OR symbol, which is our U. Okay, so if we have the numbers 0, 2, 4, 6, 8, and 10, that would be in this part. And then B is 0, 5, 10, 15, 20, which is in this part. And our union of them is going to be every number, so all of them. Okay, so union is the U. It means all of them, so all possibilities. Okay, the intersection, however, of the two events only is those outcomes that are in both of them. So this is the overlap. So we're looking for the overlap between the sets, okay, so that are in both events. We use the and symbol, which is the upside down U. I think of it as an intersection. And if there's no overlap, we can use just an empty set or the no solution symbol. So if we use these same sets, A and B, and we put them in our Venn diagram, we're just looking for the two numbers that are in both of them. So the intersection between those would be 0 and 10. Okay. So here we have this lovely Venn diagram where we have a whole bunch of colors, okay? So the sample space is going to be everything that's in our box, our Crayola washable paints. So it's going to have 12 of them in it because we know there's 12 count. So we've got to list all of those. So our sample space is all of the colors. So green, violet, turquoise, yellow, blue, red, white, brown, peach, black, magenta, and orange. Okay, so get them all listed in there. Now list the subset that is primary colors. So primary, let's call it P. So the primary colors are in this circle here. So that would be yellow, blue, and red. Okay, we have a subset that's the American flag colors. So let's do A for America. That's blue and red and white. Okay, so now we want the union between P and A. So that's going to be all of the colors that are in both of them. So yellow, blue, red, and white. Because we have those overlap. Now this one is the intersection, so just the ones that are overlap. So our intersection between those two are blue and red. Now we want the complement to P. So again, the complement is everything that is not in P. So it's all of the other colors except for yellow, blue, and red. So that would be green and violet and turquoise and white and brown and peach and black and magenta and orange. Okay, then our last one is not P or U, so our union. So it's going to be everything that's not in our two circles, so it's all the other colors. So green, violet, turquoise, brown, peach, black, magenta, orange. Okay, so let's look at some more vocabulary again. Hopefully you understood how those work. Because it's really important to be able to identify your sample space and the different pieces in it as you start to calculate probabilities. Okay, so the probability is the value represented, or that represents the likelihood that an event will occur. It can be represented by a fraction or a decimal between 0 and 1, or a percent between 0 and 100. The probability of 0 means that the event is impossible, and a probability of 1 means that it has to occur. So like rolling a dice, what's the probability that you're going to roll a number between 1 and 6 if you roll a dice? Well, you're going to roll a number between 1 and 6 if you roll a dice, okay? Events are independent if the occurrence of one does not change the probability of another. Events are dependent if the occurrence of one changes the probability of another event occurring. So if you're drawing marbles from a bag and you pull out a marble and then you put it back and you draw again, that's going to be independent because all the marbles are always in the bag. But if it's dependent, if you're going to be drawing two marbles and the first marble you pull it out and you keep it out, that changes what's in the bag. So that's going to change the probability of the second marble that you draw out. So that becomes a dependent event. Okay. And the last one, joint probability. Is the likelihood that two or more events occur at the exact same time. So we have some formulas to help us calculate probability. So the formula The probability of an event is the number of favorable outcomes, so what we want to have happen, so what we want, versus the total number of outcomes. Like flipping a coin, and I want the probability that I get heads, well, I have a 1 in 2 chance of getting heads. Okay, joint probability of independence events, so the probability of A and B is the probability of A times the probability of B. So if I want to flip a coin and roll a dice, and I want the probability that I get a heads and a 5, then I'm going to find the probability of finding heads, and then the probability of rolling a 5. So I have a 1 in 2 chance of getting a heads, a 1 in 6 chance of getting a 5. So for both of those to occur, I have a 1 in 12 chance. Okay, so let's do some of these. It says find the probability of each event of when you're flipping a coin and rolling a standard dice. So standard dice is 1 through 6. Okay, so what is the probability of getting a tails and an even on the dice? So tails, we have a 1 in 2 chance. And then an even, we would have a 3 in 6 chance, or a 1 in 2. So that would give us a 3 in 12 chance, which is a 4th. All right, the next time we want a heads and we want to roll a 4. So we have a 1 in 2 chance of rolling heads, and we have a 1 in 6 chance of rolling a 4, so that gives us a 1 in 12 chance. Okay, rolling a heads and a number greater than 3, so a heads is 1/2. A number greater than 3 would be 4, 5, and 6, so that's half of the dice, so 1/2. So that is a 4th. And rolling a heads and rolling a 7, well, a heads is a 1 in 2, but there's no 7 on the dice, so we're never going to roll a 7, so that has no chance or no possibility of happening. Okay, the addition rule says that the probability that you have A or B happening is the probability of A plus the probability of B minus the probability of their intersection. The addition rule finds the probability of event A occurring or event B occurring. So if we have the letters in the word algebra or the letters in the word geometry, where event A is the algebra and B is the geometry. So we've got the entire alphabet in this box. Algebra is here, geometry is here. So what is the probability that you are going to have event A or event B happen? So we have to find the probability of A. So probability of A is how many, that's algebra, so how many letters are in algebra? 1, 2, 3, 4, 5, 6. So we have a 6 in 26 chance. Probability of B is geometry, so 1, 2, 3, 4, 5, 6, 7 out of 26, minus their union, so what's our overlap between those? So 1, 2, 3 out of the 26. So that's what's written here. So this is our probability of A plus the probability of B. Subtract that intersection of their probabilities. We simplify, and this would give us a 5/13 chance. All right, have fun in your assignment. Good luck.